Hi there, this is a very quick video to help you contrast different concepts which are kind of similar, and hopefully it's going to get you a little bit less confused when you come to the exam. This may be the last exam video you watch, and you may be preparing for the test, so I'm going to contrast these things quickly and hopefully give you the edge you need. So let's get started. The first is overflow and rounding errors. Students get confused about this. The first thing to note is that numbers are represented with bits, and those are limited usually, right? So we have a limited number of bits for most number types. When you start to save numbers that get higher and higher, you run out of bits. Now, the interesting thing to note with numbers is usually if we're looking at the start, maybe the first bit could be saved as like the positive or negative indicator. So if I'm saving numbers in this many bits, I might use the first one to say if it's a positive or negative number. If I overflow from here and say, for example, let's say all my numbers are 1, 1, and 1, and I add another 1, it's going to go, okay, overflow, carry the 1, and carry the 1 over here, which would flip this bit from a positive to a negative or negative to a positive. That could cause a number to become very, very different just by adding 1. So it's not that it's going to just be a little bit wrong, it's going to be a lot wrong. So overflow errors are usually a lot wrong. Rounding errors are different. If you look at the way we store the numbers here, we make up the decimal place with kind of like this system. Still in powers of 2, but we're adding smaller and smaller numbers as we go. If we run out of bits, a number may be close, but it's not going to be super accurate. And that's why a rounding error would cause inaccuracy rather than a completely different thing, right? So they're both talking about errors and errors to do with limited bits, but they have different impacts, okay? All right. Compression versus encryption. No doubt these words kind of sound the same, and that's why they like to put them in the same question. The important thing to remember is compression is making data smaller by finding inefficiencies and trying to store it differently, and there's two types, lossy or lossless. Encryption, on the other hand, is locking up a message so that it's made unreadable by a third party or a person in the middle here. It's kind of like a secret code. They have two types of encryption. We have symmetric, where the key is the same to lock it and unlock it, and that would be like a shared key where that would be the same, symmetric, same on both sides, and asymmetric encryption, which is public key encryption. Okay, but this is about locking up messages. This is about making things smaller. Let's talk about symmetric versus asymmetric, okay? I said it was the same key on both sides. This is less secure because you have to share this key. And it means that on the internet, you couldn't do that easily or safely because you'd have to send the key through the internet to the other person so they can unlock the thing that you need to lock. So it's not very, very safe. Asymmetric means the key is different on both sides. We have a public key and a private key. The public key is used to lock the message or encrypt the message. The private key is used to decrypt the message. This means that someone on the internet you can share your public key with, they'll lock up the message and send it to you, and only you can decrypt it, right? No matter who has the public key, only you have the private key which can decrypt the message. So sharing your public key is fine, and you keep the private key. Okay, phishing versus keylogging. This is all about computer security. Phishing is, the key concept for phishing is that you're using something trusted in order to trick someone to give up information or data or something like that. So it's a trick, it's using trust, some trust. So either it's a phone call where someone says, hey, I'm from the bank, or it's a website that looks real but it's not, and it's trying to take information. Keylogging, on the other hand, is a secret program running on your computer which records your keystrokes. So it's maybe attached to another program and then it gets installed, or it's a secret thing running which is grabbing your data as you're typing and you don't know. Okay, let's look at binary and the idea of like total value versus the total numbers available versus the highest value. There's a slight difference because the lowest value, usually when we have bits, 0, 0, 0, that would be the first number, right? And the highest number would be 1, 1, 1, where you have 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, right? Which is 1, 2 plus 4, which is 5. But no, it's not. It's 7. Sorry. So it's 7. The 7 is the highest number, right? But the total combinations, if we include the 0, is 8, which is 2 to the power of 3. So however many bits you've got, there's 3 bits, 2 to the power of 3, right? Because each one has 2 options. So it's 2 to the power of 2, right? It's the powers, and it's 2 to the power of 3, right? So we have 3 bits, 2 to the power of 3. If we have 5 bits, it's 2 to the power of 5, or 32 combinations. The highest number you can represent with that would be 31, because you include the 0, right, to make 32. So don't get them confused. Highest value versus the total. Okay, these are and or. You'll see these when we do conditional statements, when we're looking for conditions, because we like to test 2 conditions at once or 2 things at once to see if they're both true or one of them's true, and have an outcome at the end. So we represent this with a kind of a symbol like this, gates, where we have A and B, right? And what's the outcome? So with an AND operation, that's a condition, like testing these things. Both of them have to be true for the output to be true. So you can represent it in a table here. So if we imagine 0 is false, then if they're both false, the outcome's false. If A is false and B is true, then the outcome's still false, because we need both to be true for the output to be true. So AND, both true, output true, or is either one is true or both, and the output's true. And not, we'll just flip the result there. Okay, so remember those things. You can use them in conditions, right? So maybe you have a variable x is true or false, and y is true or false, or some condition x is greater than 5, and y is less than 6. Those 2 conditions can be put together in a statement. Okay, saving variables. Important thing to note is, if you're trying to find the final value, recognize that this side is always done first in an equation, right? So in this statement, 1 is saved into temp. Now temp is 1. At the second line, temp will be replaced with the value of temp right now, which is 1, right? We've saved 1 into temp. So this will get replaced with 1. 1 will get added to 2. That's 3. And then that 3 will get saved into temp again. So a temp gets updated. Now, here, the current value of temp is 3. So this gets replaced with 3. 3 plus 3 is 6. That gets calculated and then saved into temp. So the final value is 6. Okay, Internet versus World Wide Web. The Internet is a mostly hardware thing. It's consisting of all the devices, network, cables, routers, all that stuff, servers around the world, mostly hardware-based, providing the ability to send data. What has grown on top of that, and kind of like on top of that, kind of like the leaves of a tree, is the World Wide Web, which is mostly software. It's the websites, all those connected websites that we use every day. This is the kind of thing that we mostly use when we think of the internet. We're kind of thinking about the World Wide Web, but actually the World Wide Web is just a software kind of mesh that's using the internet as the backbone. Okay, passwords. We know passwords. Passwords should be strong. We should use numbers, letters, all that stuff. But it's really basic level of security because it's based on something that you know, right? You have to remember it. You might write it down. To increase the security, we have to combine this with multi-factor authentication, as in multi ways to determine that you're really who you are. So therefore, if there's something that you have, like a phone, a device, or an account that they can send a message to, then that would increase the security. Additionally, if we have something that you are, that will also increase your security as well. So combining these multi-factor ways to authenticate you, like a fingerprint and a phone and then your password, that makes security much stronger. Okay, citizen science. Citizen science is a way of using the crowd or lots of people to gather data. It's related to crowdsourcing, where you're getting things from the public and you can collect things on a large scale. Simulations are programs that we can run to test theories out, kind of scientifically. They're not always super accurate, but They're useful because they save us time or money to predict what's going to happen. Okay, we've talked about public key versus private key. The main thing to remember is the public key you can share with everybody. It's used to encrypt the data, and you can't use it to decrypt. Private key is kept secret, and we use it to decrypt, held by the receiver of the information. Okay, copyright versus Creative Commons. Copyright is the most restrictive version. Creative Commons is a system for allowing different levels of restriction, right, for creators of content. And public domain is everything's kind of shared without permission. It's all open, right? So it's a spectrum. Okay, fault tolerance versus redundancy. Fault tolerance is the ability of a system to handle faults, right? So if something goes wrong, can we handle it? And redundancy is just one way to handle those faults. For example, having extra copies of things, having additional drives, that's redundancy. So it's just one way to handle fault tolerance. Bandwidth versus latency. Bandwidth is the amount of data you can send in an amount of time. And, and latency is the time it takes to get from one place to another. Okay? This one's measured in bits per second. This one's measured in milliseconds. TCP versus UDP. TCP has error checking, has packets, and we can resend missing packets. It's fault tolerant. It's good for accuracy, but not for speed. UDP is good for speed. It's less tolerant. It's loss tolerant, means if something gets lost, it doesn't matter, or it doesn't care. It doesn't have connections, so it doesn't say, did you get this? Have I got this? And it doesn't use confirmation. So it's faster, it's better for gaming and videos. Okay, rogue access points. Look, we have a network here. It could be a strong network. We have security, but then someone connects their router here with no password. That's a rogue access point. Okay, so this is a router. These are all routers here, but this rogue access point means that we can get into this network through bypassing the security because someone connected their own router. Okay, algorithms. Algorithm is a series of steps to solve a task. A procedure is a piece of code which implements an algorithm, right? So a procedure is more of a programming thing, but algorithm is really just a series of steps. So that's kind of the difference. Linear search versus binary search. Okay, we're looking for a number in a list. Linear search is when we go through the list one by one, from left to right, scanning for it. The results, at the worst case, would be we have to search the whole list to see if it's there. Okay, so we search for the list that way. Binary search, however, divides the list into two each time. Binary meaning two, right? Binary. You've done that before. And this way, the list we search in the middle, and we search, okay, is it bigger or smaller? Well, if it's bigger, then we can look in this half, and we can divide it. And that means that the results are much faster to find the number. Okay, unsolvable and unreasonable. You guys can keep in. Unreasonable problems take a lot of time to solve. So therefore, unreasonable, it's too long to wait, basically. Usually that's exponential, so the more things we add, the more number of things, it raises the complexity to another power. Some problems are unsolvable though, and you just can't. No matter how much time you get, you won't be able to solve the problem. And finally, this is data versus metadata. Big confusing topic. Data is the picture. If we talk about a picture, that's the pixels, the actual pixels of the picture we're looking at. Whereas the metadata is things like the name, the author, the camera you used, the date, the GPS location. Those kind of things are metadata, which is data about data. Okay, and I hope this helped review. That's it. I'll catch you next time. Best of luck.